Hello again. In this lesson, we will see how to create the famous Fiat beams in the family editor, and the same at the columns, we will adapt it to our project. Go to File tab and hover over New, then choose Family. This will take you to the family template browser. We have seen what a template is in the previous tutorials. From here, let's scroll down, and for this case, the template will be metric structural framing, beams and braces. Select that and click Open. Before we begin, let's go to AutoCAD and see the beam we are about to create. I'm in AutoCAD now, and our beam will look like this. It has sloping sides, and at the end of the beam we'll have 0.3 meter or almost 1 foot depth, and the slope angle will be 5.7 degree. You can see that we have tiles above the beam, and we will provide water canal for the tiles to protect the beam from rain. And finally, at the center of the beam we have 2.05 meter or 6 foot 8 depths. Oh yeah, you are right. If you stand there, you will not be seen. This is deep enough to cover an average human. And finally, its total length will be 44 meter. Now I think we are familiar with the dimensions. Let's go and create the beam in the family environment. And later we will check it if it's going to flex. Let's go back to Revit. I'm in Revit now, the family editor. Delete the already created extrusion in here. You can see there is only one parameter already created, the length parameter, and the equality constraint. Like I always do, let's change the unit setting to meter, go to Manage, Project Units, and change the length unit to meter, round it to 2 decimal places, let the unit symbol be meter, then click OK, and OK again out of it. First, let's open the front elevation and put the ref level and front elevation side by side. Now let's create the reference plane that govern our beam. And next we will create the parameters that the end user will use. Go to Create tab, and from the datum panel click Reference Plane. Create one below and one above the reference level. This plane will govern part of the beam below the floor level. One thing you need to notice in here is the beam in this project is an inverted beam. So finally I will give it some offset to put it in the proper place. And to do that, this plane will be important, and from the Modify tab, Measure panel, click Align Dimension. To create our first parameter, dimension it starting from the ref level. By starting dimensioning from ref level, I am giving it more power over the newly created plane. So when I flex it later, the part that's going to move it, the new plane, pay attention to the hierarchy when dimensioning. Select that dimension, and from the Level Dimension panel, select this small icon to create a parameter. Give it a name. The name has to be descriptive like always. Mine will be beam underscore depth underscore below level. The type of parameter will be length. Keep it as a type and click OK. Now our first parameter is set, and you can go to family type to flex it. Let's try 0.6 meter and hit apply. It's working as we intended. Let's dimension again from a newly created plane to this one. Now the hierarchy will go from the ref level to the lower plane, and from the lower plane to the upper. I will select the dimension and create another parameter. Give it a name. Simply I will name it beam depth small. This is gonna be our end beam depth. Now if I go to family type and flex it, I can see it's working okay. Now let's come to our inclined angle. This is a bit tricky, so pay attention. Let's hit RP for reference plane, and when creating it, make sure it snaps to the intersection of these two reference planes. By doing that, you are specifying the point of rotation, and that will determine by the point of intersection. Let's create an angle parameter. Measure this angle and select it to create a parameter. Give it a name. I will name it slope angle. Click OK to finish. And to create the same parameter to the right, don't start from scratch because it's not gonna work. So what you do is select the reference plane and the angle together and mirror them to the right side. Now let's flex to see if it's working. Hit apply. This is working fine. Finally, let's create our last parameter, which is the beam depth at the center. Create the reference plane by going to the Create tab, and from the datum panel, choose reference plane. Measure from the lower part, and select the dimension and give it a parameter. Let's give it a name, beam underscore depth underscore large, something like that. Let's flex to check it. Now I think we are done with our parameters. To create our beam, from the Create tab, let's use Simple Extrusion. For the work plane, since I'm in the front view, let's use Center Front Back Plane. For my creation method, I will use Pick Lines and check the lock icon from the option panel for the lines to be locked with my reference plane. Pick the lines that determine the beam shape like so. From the Modify panel, choose Trim and clean the lines. Let's change our view to Shaded to see the volume that we just created. After cleaning, hit the green check mark to finish the extrusion. From here I will go to Family Types dialog box to create a new type for Fiat beam. Hit this new icon for new type, give it a name. My first beam will be Fiat beam. Give it the value for the smaller depths, I will give it 0.3 meter, and for the larger depths 2.05, for the length 44.06 meter. The slope angle will be 5.7 degree, and lastly for the depths below, give it 0.22 meter. Hit apply to check if the beam is flexing correctly. Everything is working fine now. Now let's go to the left view to create the width of the beam. You can see the extrusion depth is the default depth. To create the width parameter, let's create a reference plane that governs the width of our beam. I will select this reference plane and right click and choose Create Similar. Create one on the left, then mirror it to the right. Now go to Align Dimension and measure between reference plane, and create an equality constraint by hitting the EQ icon. This will keep the distance equal from the origin. Next, measure between the end reference planes and create a parameter. Give it a name. This will be our beam width. Now select my extrusion and use the creeping icon to attach it to the reference plane. Attach and lock it. Do the same to the other side. Now go to the family type to test it. Give it a different value and hit apply. This is working correctly. Since I'm in the Fiat type, I will give it the width of Fiat beam. It's 0.5 meter, so put 0.5. I think we are done with the beam. In the next tutorial, I will create tiles above the beam. Lastly, don't forget to subscribe and hit the bell icon for notification for upcoming tutorials. And if you have any question, you can post it in the comment section.